Hello students, I hope you are good, well and fine, and today we will be continuing our topic statistics, and we will be learning about more definitions and more examples through which we can get what the definition says. So let's move today's outline. So in this lecture we will be discussing about graphical representation of data, and then the bar graphs, histograms, and the frequency, polygons, and the curves, and pie diagram if we are left with the time. I hope you will understand each every bit of the information. Let's jump into our first topic. So graphical representation of data. So graphical representation of data, we take the representation in various forms, in the form of bar graphs, histograms, frequency polygons, frequency curves, cumulative frequency curves, or ogives, or pie diagram. So in this we will be discussing for here today's lecture. If time permits, we will be covering this also. Okay, if time permits. Okay, now let's see what are our bar graphs, or how we are going to graph them, represent them, how the information of data can we recover from the bar graphs. So let's see. So bar graphs, let's try to understand by an example. A family with monthly income is this much. So monthly income is 20,000, had planned the following expenditure. So the family planned an expenditure per month under various heads. So draw a bar graph for the data given below. Let's see how our bar graph will look like. First of all, make a table. So heads are like this: so grocery, the rental, the education of the children, the medicine, fuel consumption, entertainment, and other miscellaneous things. Okay, so if you see in grocery, family expenditure is 4,000. The all things are in thousand, so that means 4 means 4 times 1,000. So this is 4,000. For rent it is 5,000, for education it is 5,000, for medicine it is 2,000, for fuel is the same, entertainment and for miscellaneous works both have each of 1,000 expenditure. Okay, let's move to next, so that you will see how we are going to build our bar graph. So first of all, let me give you a hint. So just draw two axis. In one of the axis we write our heads, or we write what is our name for the major expenditure, and on this y-axis, you say in this y-axis we write our rupees, or the expenditure in rupees in thousands. Okay, so let's see now. Here if you see, here is our heads on the x-axis, and here on the y-axis our expenditure in thousands are given. So this is my intersected point, or the 0 point. Okay, now for grocery I make a bar. Bar means a vertical rectangular shape. This is my bar, okay, which is shaded. So this is my bar. So each one of these horizontal rectangle, sorry, the vertical rectangle standing on the x-axis are all of my bars. Okay, I hope this is clear. This vertical rectangle standing on the x-axis, so bar. Okay, so I hope this is clear. So that's why we said this is my bar graph. Now we know for grocery how much we how much was the expenditure. It was 4,000. If you see, it was 4,000. So we marked on the y-axis, we marked this one means 1,000, this 2 means 2,000, this 3 means 3,000, and so on. Okay, till we drew to till 7,000 only. Okay, So we know for grocery it is 4,000. So we make our vertical shaded rectangle of the height of 4,000, or here in this case it is 4. So see, 4 means 4,000 because we are taking every unit in thousand. So 1 means 0 to 1 means 0 to 1,000, 1 to 2 means 1,000 to 2,000. I hope this is clear. So this height, is my 4. This rectangular height is my 4. You can take any width. The width is not fixed. So in bar graphs, graphs, width of a rectangle not fixed. So you can take any width of rectangle. It is not important here. You will see the importance of width in histograms graphs. Okay, so now for rental, let us make another vertical rectangular piece of the height. If you see from the previous table, the expenditure was this 5,000. Okay, so let's see the previous. So expenditure was of 5,000. So this rectangle, this is of height 4, and this will be the rent height is 5, and same goes for the education. It is also of 5. Okay, and for medicine and fuel, the expenditure was 2,000 per each, and for entertainment and other miscellaneous things, it is 1,000 each. I hope this is clear. So this is 1, this is 1, this is 2, and 2,000. Everything is in thousand. That means 2,000, 2,000. Here 5,000, 5,000, and here 4,000. So if a bar graph is given to you, you can easily take out information. So suppose if this bar graph is given, then I can make I can make a table from this saying that grocery expenditure is of 4,000, rental expenditure is of 5,000, education expenditure is of 5,000, and etc. I hope this bar graph representation of data is clear to you. So let's move to next for the histograms. Now for histograms, it is quite similar to the bar graphs, but there is a small difference you will see. So in histograms, it is also a rectangular representation of grouped or the continuous frequency distribution. The main thing is here is the continuous or the grouped data frequency distribution is here. In histograms, we usually represent the grouped or the continuous and the continuous frequency distribution, in which class intervals are taken as base. So the base or the width of the vertical rectangular representation, or the vertical rectangular rectangle or figure is of the base of the class interval, and height of rectangle are proportional to corresponding frequencies. So to draw the diagram for the histogram, class intervals are marked along x-axis. Always remember the class intervals are going to be marked on x-axis, not the y-axis. And on y-axis we use a suitable scale according to our class intervals, such as area of drawn rectangle are proportional to corresponding frequency. So let's move, or let's see from examples. So let's jump into the example. So draw a histogram of the frequency distribution. So frequency distribution is given to us. The class is in age in years. So 0 to 5 years, 5 to 10 years, 10 to 15 years, 15 to 20 years, and the number of students to their respective classes or the class intervals is 72, 103, 50, and 25. Okay. So for this, we are taking the class interval on x-axis. For 1 centimeter of scale, we are taking 5 years, and 1 centimeter in the y-axis, we are taking 25 students. So let's see. So here is our histograms. If you see, histograms are connected, or bars are touched to each other. In bar graphs, they are not very close. Okay, so but in histograms, they share their boundaries, one of the boundaries. So here you see the base, the class interval in ages is 0 to 5 here. 10, let me draw another. So 0 to 5 here, 5 to 10 interval is here, and 10 to 15, and in this similar way 15 to 20. On y-axis, age is given 25 and 50, 25, 50, 75. Each class interval length is 25, 100, and this 125. Now, according to the data given in the table, we know from 0 to 5 we have this. If you see from this the table, 0 to 5, the 72. Okay, so 72 will be there. So let me draw it again. So 0 to 5, 0 to 5, 10, 15, 20, 25, 50, 75, 100, 125. We know 0 to 5, it is 72. So this will be my, say, 72. Okay, so 72. Now 5 to 10 is 100. 5 to 10 is my 100. So this vertical rectangular figure of height will be of 100. So this is my 100. And base, or the length, or sorry, the width of the each of the rectangular figure is of 5 units. Okay, so 5 units. Now for C, according to the information given on our table, we will draw the respective as seen in this figure. You can easily see from the raw data given in the frequency table. So I hope this is clear to you. Let's move to next example. If you see, we previously talked about the weekly wages of workers in a factory. Okay, so here is the same example, but here we will be drawing a histogram for it. So let's see directly. Let's see the histogram. So for the frequency table is given to us that in the interval of 1000 to 200, the number of workers are 26. For 2000 to 2500, it is 30, and for 2500 to 3000, it is 20, and for 3000 to 5000, it is 16, and for 5000 to 5500, it is just one worker. Okay, so now if you saw, the class interval was not equally distributed. That in the previous case, in the first class interval, length was 1000 and other was 500. So in these cases, what we will do, we will be taking a method to find the heights of a rectangle, so that the heights are proportional to their frequency. So first step, write interval h of the least interval. So the least interval length is 500. Here h is equals to 500, and then redefining the frequencies of classes by using formula. So what formula we are talking about? The formula present here. So redefining the new frequency class is h is 500 here, and the class interval times the frequency of that class interval. So let's see. Here this is my class interval, this is my frequency. Now the 500 times the class interval length times the frequency. It will be 13. The similar things happen in each of the case. So 500 divided by the class length times the frequency, 500 divided by the class length multiply by with their frequency, 500 the class length divided by the frequency, 500 divided by the class length multiply with their respective frequencies. I hope you are facing no difficulty with finding out the class length interval. So it is just nothing, the upper limit minus the lower limit. It is just 500. In this case it is 5000 minus 3000, which is equals to 2000. Let's move to next. So here for the from the previous information, we took x-axis and mark 1 centimeter equal to 500, and on y-axis we took 1 centimeter equal to just 5. Number of workers is equals to 5. That means for in x-axis each 1 centimeter is of 500. That means this is my 500, this will be my 1000, here 1500, 2000 and so on. Okay, and on the y-axis the number of workers for in every 1 centimeter is 5. So here 5, now 10, 15, 20 and 25 till 30 and so on. Okay, so now the information given to me was in from 1000 to 2000. The number of the frequency was the new or the redefined frequency was 13. So this means this line is my 13, and from 1000, if you see this point and the 2000 point, the width is of 1000. So width remains the same. So width is 2000 minus 1000 is 1000. So the width of the vertical rectangle figure remains the same, but the height gets redefined by the formula is 13, and for this is height is 30, for this height is 20, for this height is 5, and for this is the respective value we calculated previously. So I hope this all were clear to you. Let's move to next. So let's see the difference between bar graph and histogram. So in first in histograms there was no gap. If you saw the examples, no gap was present in between consecutive rectangles, but as comparatively in bar graph there was. In second, the width of bar is not significant in bar representation, but in histogram representation of data it is very much significant. Okay, and the third difference is in histograms the area of rectangle are proportional to the frequency. So area of the rectangle are proportional to the frequency. However, if the class size of the frequency are equal, then height of the rectangle are proportional to the frequency. I hope this is clear. This third point is talking about the redefined formula. Okay, if you paid attention to that. So let's move to next to understand the how we are going to plot the frequency polygon. Now a frequency polygon is also a form a graphical representation of a frequency distribution in which a polygon is to be constructed. So how we are going to construct a polygon? So with help of the histograms or without help of the histogram, you will follow certain steps in both of these two cases. So let's see how we are going to do if we are given with a histogram. So let's directly jump to our question. So this, if my histogram is like this, okay, so you now you learn how we constructed our histogram. So suppose you constructed a histogram, for example, like this. Okay, then you in order to make a polygon, you just have to do nothing, just find out this midpoint of every upper length of the vertical or the vertical rectangle standing on the x-axis, and then just join them. Okay, and just join them, you will get your polygon. And what, okay, I hope this is clear to you. Now let's see by an example. For this the class length is of 10 units, because upper limit minus lower limit, the 30 minus 20 will give me 10, 40 minus 30 also gives me 10, and the midpoint for this is same as the midpoint for this. That means 30 plus 20 by 2 will be my midpoint. This means 50 by 2, which is equals to 25. So this is my 25, this will be my 35, this will be my 45, this will be my 55, the 65 and 75. Now just join all of them, we will get this red small segments of lines. And now joining this 70 to 80 is 75, and the previous 10 to 20 class interval to 15 will give me my complete diagram. I hope this was clear to you. Now for the frequency polygon in this example, you can easily draw a bar histogram for this example. Let me directly jump to how we are going to construct or how we are going to polygon make a polygon out of it. So just find out the middle points of each class interval and then mark it on the upper side of the rectangle, and then just join them. You will get your polygon. Okay, so this is the case where you are given with a histogram. What if we are not given with a histogram? Is just quite easy. So if a histogram is not given to you, in this case you will just find out the class marks. So just find out the class marks. Class marks was the average of the class interval. That means the upper limit plus the lower limit by 2, and then plot these points and then join these points. You will get your required polygon. For example, in here the class interval is 0 to 10. That means 10 plus 0 by 2 is 5. For here 20 plus 10 by 2 is 15, and for this is it will be, I think, not this, so 45, I think. So 45 minus not 45, it is 50. So the difference is 50. So 70 minus 20 divided by 2, which is equals to 50 by 2, which is equals to 25. So this must be 70. Okay, so now my class marks are 5, 15 and 25 with their respective frequencies. Okay, now just plot them as follows. So making this or just marking my midpoints 5, 15 with their respective frequency: 15, 12, 25, 10, 35, 4, 45, 11, 55, 14 and 65, 4 and 0, 7.5. For this we just half the frequency of this. That means the frequency for this is 15, and dividing it 2 it will give me 7.5. That's why we use 7.5 here. Okay, clear? I hope this was all clear to you. Let's Thank you for this session. So we will be meeting again with a next topic. Thank you.